bouncing ball simulator program. Let's take a look at what we have so far. We have got a ball that starts in the middle, kind of top of the screen, and it bounces up and down forever. This is, it's what's called a perfectly elastic collision. Of course, in the real world, you'd have air resistance, and you'd have, you don't have perfectly elastic collisions. There's always some type of energy lost. But for this, this is computer. We can do what we want. So what I want to do here is just, add a little bit of left and right movement to the program. Okay, so since we have dy, that's up and down, we're going to have dx. So ball.dx equals, let's just use 2, for example. So that's going to move to the right. So in this case, it's not really acceleration, it's actually the speed. There's no force like gravity pushing the ball left or right. So we're just going to start it out at +2 and see what happens. So what we'll do is, in this case, ball.set x, and it's ball.xcore and plus ball.dx. So we're changing the current x-coordinate to the current x-coordinate plus the change in x, which is its horizontal speed. So let's take a look at that. Okay, so you can see how it's kind of falling like a real ball would, and it bounces right off the screen. So let's do something about that. So just like we did here, checking for a bounce, we're going to check for a wall collision and do the same thing. We'll reverse the direction. So if the ball.xcore is greater than 300, we're just using 300, then we need to reverse it. So it's the same thing, ball.dx times, oops, did I do wrong there? Okay, ball.dx times equals -1. And on the left side, if ball.xcore, don't forget the parentheses, a lot of people do, is less than -300, then ball.dx times equals -1. Okay, so let's run that and see what happens. Okay, so it bounced. Now notice it's not quite at the edge of the wall. We could play around with the numbers and get it correct, but just for now, this is all we need, just for demonstration purposes. Okay, so I'm pretty happy with that. So one thing you've possibly noticed is that it seems like it's slowed down just a little bit. And this is what happens, especially once we start adding objects to the screen and doing stuff with the movement. So to fix that, at least to maximize your speed, what we can do is we do this command, wn.tracer 0. And what this does, it actually turns off the screen updating. So if I stop here and I run the program, you're not going to see anything, because tracer stops the screen from updating. And I might get locked out here. Oh, okay. So what I want to do is, inside the while true loop, I can put it at the beginning or the end, doesn't matter. We call the update method, and that will redraw the screen every time we go through here. This will give us basically our maximum speed. So let's take a look at that. Okay, so I don't know if it comes across in the video, but you can see how hopefully it's much smoother. And once we start adding to this, you'll see it's quite a bit different. Okay, so let's close that off, and yeah, we'll leave that at that. So that was left and right movement, which is very similar to the up and down movement, except for the difference is we're not using gravity. Okay, so come back for part 3. And if you like what you see, subscribe or like below. Thank you.